Please take your seats, folks in the back. So this keynote for me is very emotional, and I want to kind of take a second to explain why. So our next keynote and I had lunch in New York about probably 7 or 8 years ago, and very kindly agreed to meet me and have lunch. And we sat down and had lunch, and as we were finishing lunch, I said, "What do you think about CBRS?" And he said, "What's that?" And we started to talk about it. I sent him some information, and this gentleman had the very first CBRS network, real CBRS network, installed in his building, 345 Park, the NFL building in New York. It was the very first one. Crown Castle did it. Unfortunately, couldn't figure out how to make money at it, but we had a long relationship, and I hope, from my standpoint, that we've become friends. John Gilbert is a giant in the real estate industry, has been for many years, and I'm really honored that now he's in Florida, lucky guy, that he was able to come and visit with us today. So, Nick, you want to hit that? So, please welcome John Gilbert. Thank you. John, thank you. You well.
I'm not going to sing this song, so you can all rest assured. Thanks, Rich. It's really it's been interesting for me today. A lot of people I haven't seen in a long time. Darlene, of course. I did the math, Darlene. It was 32 years ago that we first met. I was qualified. Yeah. I wasn't. So I really want to talk about three things today. Electricity, connectivity, and ultimately artificial intelligence. And kind of bring you, some of our experience as Rich kind of touched on. For 30 years, I was Chief Operating Officer for the Rudin Management Company, largest privately owned real estate company in New York, 15 million square feet, 10 of it office, 5 of it residential. And we launched a software company that I'll finish my talk discussing. But Jack Rudin used to always say the first person he'd call when he'd build a building was the head of Con Edison, which was our local utility. I used that line, and Elliot Spitzer, who was governor at the time, said first person my family calls is our banker when we build a building. So he thought it was kind of funny. That was before Elliot got in trouble. But as we talk about artificial intelligence, electricity is a huge, huge issue. You're going to start to see, and you've already seen it, communities really, really upset. No, you're not putting that data center here because our electric rates are going to go up in a big, big way. You look at what's happened in New York State in terms of the electrification, move away from natural gas. Electric rates have skyrocketed. And I think what you're going to see, and the Trump administration has basically come out and said, you got to do this if you're going to build a data center, which is you got to supply your own energy. So these things called SMRs, small modular reactors, literally are going to be put into the ground, and they're going to be generating electricity. And it goes back, in my mind, to the debate and a great book that you probably have already read, but the Devil in the White City, which was the discussion about the World's Fair in 1882. And it was the moment when Tesla and alternating current beat Edison and direct current. And so I think what you're seeing, and so many things of coming full circle as these SMRs are deployed, we're back to Edison and direct current. And the alternating current, in terms of the large electrical grids, are always going to be there, but they'll exist in parallel. And a dear friend of mine runs one of the largest utilities in the country. We had lunch a couple weeks ago. And I said, Gil, what's going on in your life? He says, you're not going to believe it. I currently have on my desk, as a CEO of large utility, currently on my desk, applications to create 29 gigawatts of data centers. I said, well, what's your current peak load? 13 gigawatts. It's literally more than double his current capacity in a peak load situation. So it's a big issue. Water is also going to be a big issue as we try to get to this world of artificial intelligence. Connectivity. I thought I was going to run through a little history. Anybody know when the first transatlantic telephone cable was laid? 1955. We then had, that was 82 simultaneous calls. My grandfather was the chief engineer on that job. Fast forward, flag, fiber link around the globe, optical light being pushed through glass, world is connected on a broadband basis, unbelievable. And then suddenly, our friends in Ukraine and our not so much friends in Russia start scraping the bottom of seas and rivers to exploit ultimately or destroy global connectivity. Big issue, huge issue from a safety standpoint. And in this room, we take that macro discussion, we bring it to a micro level, which is how do we distribute wirelessly on a broadband basis within buildings, within built environments. And to me, Rich mentioned CBRS. I was like, when I started researching CBRS, I said, this is the Holy Grail. Are you kidding me? FCC is actually bequeathing to property owners a huge swatch of network that we can ultimately use to exploit, to create private 5G networks, ultimately help us rent space. And there's been some, trips and falls along the way. But net, why do we need those networks? Why do we need that granularity? And this is where I'll switch into what we're doing in terms of Nantum AI. So 2008, Gene Bonnyberger and myself were asked to come over to Con Edison, big meeting, they want to talk about the future. And they showed on a graph in this conference room what was going on with the grid in 2003 when 45 million people lost power from Montreal to New York and from Boston to Ohio. And they raised a really, really fascinating question, which was as follows. Hey, we, Con Ed, had a 45-second early warning that something bad was going to happen. We want to provide you, Rudin, and your friendly and unfriendly competitors at least 30 seconds of that early warning. Do you want it? We're like, absolutely. Are you kidding me? Signals coming from the utility. We can use that ultimately to shut down key infrastructure, key machines so they don't get damaged if we have a spike or a dip within the grid. We walked out of that meeting. I said to Gene, that's a great idea. How the heck are we going to do this? How are we going to be able to take that signal and then actualize it within our buildings within 30 seconds? We walked around the corner on 14th Street. There's a little divey pizzeria. Sat down, pulled my phone out, put it on the table. We started playing mental ping pong back and forth. What about this? What about that? What about this? What about that? I looked at my phone and I said, this thing's got an operating system. Why don't our buildings have operating systems? Let's go find the men and women that have created a digital operating system for the built environment. We said, yeah, let's go do that. We spent the next 4 or 5 months looking, nobody had. So we set out to build it ourselves. And God bless the Rudins, they let us do it. The original prototype was called DBOS, Digital Building Operating System. We then rebranded it as Nantum AI. Nantum is derived from an ancient Algonquin word that means prayer or blessing. We look at this product, this system, this platform as a blessing because it did answer our prayers. For the panel that Darlene moderated, everybody was talking about we need a single operating platform where I can see emergency data, I can see water consumption, I can see electrical consumption, I can see indoor air quality, I can measure temperature. That's what we created. So our customers currently exist. Our largest customer is JPMorgan Chase. We're in every one of their buildings that they occupy across the United States. In discussions with them to take us to India and to London. Where, as Joe mentioned, they're working very closely with SoftBank. SoftBank is a customer of ours. We are in their HQ in Tokyo. I was in Tokyo in September meeting with them. We went out to dinner. Server comes over to us, and I said to her, I said, wow, your English is so great. You must have studied in the United States or gone to school or visited there. She said, no. I said, well, how'd you learn English so well, so articulately? She said, ChatGPT. I said, ChatGPT is teaching you how to speak English. At that point, I said to myself, there is no issue in terms of artificial intelligence being overhyped. And then just last week, when we saw what Anthropic did in terms of the release of two products. Somebody mentioned here also on Darlene's panel, we got to get our arms around leases. Well, Anthropic now has an AI product that you can put any contract, lease, contract, whatever, and it will analyze, spit it back, tell you what the issues are, what you should be negotiating, what you shouldn't be negotiating. Second product they put out was a product that will help people code. In that single day, following that launch, $300 billion lost value in a handful of stocks, including Reuters and Salesforce. Why? Because AI is going to eat their lunch. These two products are simply going to eat their lunch. So at the end of the day, I look at this and I'm like, okay, young woman from Japan learning English, $300 billion in lost value in the stock market simply by the first two products that Anthropic launches. So for us, in Nantum AI, we look at this very, very simply. In order for buildings to operate efficiently, you need a brain. I look at Eric Kandel. Eric Kandel won the Nobel Prize in 2001 for in effect disproving Einstein. Einstein said, only one issue in the universe that's constant, speed of light. Eric Kandel says, you're wrong, Einstein. The chemistry of memory. The chemistry of memory is a constant from a biological and chemical standpoint. So as we look at, what really is artificial intelligence? Artificial intelligence is simply memorizing patterns. For us in Nantum AI, I memorize water consumption. I memorize electrical consumption. I memorize typical occupancy patterns. And then ultimately, when those patterns get out of whack, alarms go off, and I can ultimately look at that and see where the problem is. Water, perfect example. Water consumption suddenly peaks in the middle of the night when it shouldn't. I got a toilet in the basement, flushometer broke. That water's rushing its way to the elevator pit. If it had been allowed to run, that elevator would have been out the next day. Smaller building, so probably both elevator pits would have been out. We caught it, grabbed it, understood it, fixed it. So when you look at predictive analytics, great, we can predict things, but what we really need to do is to prescribe how to fix what we can predict. And that's what Nantum AI does. That's what we focused on in terms of running our algos, identifying those patterns, memorizing those patterns, and then ultimately seeing how we can fix it and what the correct pattern should be to get it back into frequency in the right cadence. So it doesn't matter indoor air quality, water consumption, electrical consumption, steam consumption, natural gas consumption, occupancy. As Darlene said, we all have this sensor in our pocket, our iPhone, that is an occupancy sensor. And how do we measure occupancy in many of buildings? We scrape Wi-Fi data. We identify, we make an assumption based upon the building, how many devices you're actually carrying. So for those of you in this room that ultimately create wireless networks, ubiquitous wireless networks, there's nothing more important to the operation of buildings than what you're doing in terms of grabbing that granular data and making it actionable. Nothing. If you remember nothing else from what I said today, the more granular the data we can collect, the more valuable it is. So the question was asked of Darlene's panel, hey, how do you talk to property owners? A guy who, spent most of my professional career operating real estate. Care about one thing and one thing only. How do I lease space? So as you look at this network, this wireless network that you all create, what are the applications? What are the use cases that ultimately can ride upon that? I think the question was asked earlier, well, where do we get to when there's 5 bars everywhere? That's simple. It's applications riding on that network. What does it do for me? How does it create value? Does it make my life easier? Does it make my building more efficient? Our software is 10 cents a square foot. I can save you 50. So but I need a wireless network to ultimately grab the data to come back to my algos and back to the brain so that we can create value. SoftBank, Tokyo, HQ. We said, sign them up, we said, we'll save you 5%. That was the threshold. Ended up saving 8%. They only listened to us 60% of the time. So one of the things that we've created is a report card. Okay, we gave you 500 recommendations. How many did you listen to? How many did you actualize? Well, if you would have done all 500, you would have saved this. You did 50%, you saved that. So it's immediately, and forgive my French on this one, but Jack Rudin used to have on his desk, it was actually a can of Right Guard deodorant with a label on it. And the label said bullshit repellent. And he would sit in a meeting, and Jack was one of those people who didn't say a lot, but when he spoke, everybody listened. He would take the cap off when he didn't believe somebody in the meeting, and he'd spray him with the bullshit repellent. Nantum AI is bullshit repellent because the disconnect that can happen between the C-suite and the engineers, what CFO or COO is going to try to convince an engineer that they're wrong and he's right or she's right? Not going to do it. But if I have that bullshit repellent ultimately saying, hey, you listened to us 50% of the time, had you listened to us 100% of the time, it wouldn't have been 8% savings, it would have been a 14% savings. So at the end of the day, artificial intelligence, and I go back to, I think it was Barcelona in a Pablo Picasso museum, and the very last exhibit was Pablo Picasso talking about computers. Perhaps the most prolific artist ever, right? And so if you Google what does Pablo Picasso think about computers, he said that they were useless because they only give us answers. And what's really important in life is asking the right question. And when you look at artificial intelligence, and when you really begin to see the value and the power of artificial intelligence, you'll see that it's all about the questions that it's being asked. And that really is, in my mind, what it's all about. Because, everybody, again, on Darlene's panel was asked, how do you get to owners? How do you ultimately get inside their brain? And it's really simple. Understanding the problems they're trying to solve, and you walking in the door with the answer to solve that problem. Since leaving Rudin, I've been able to work with some genius engineers. And they'll come to me and they say, "Oh, John, I've got a new issue or new solution." I'm like, "Well, what's the problem you're trying to solve?" If I care about that problem, I'm all ears. If I don't care about that problem, we're done. Short meeting. So focus on the problems. Focus on really understanding what real estate, what the game they're in. And it's all about renting space. Net. So, I'm short. I could keep going, but we could open it up to questions. I think to me the most important aspect of what each and every one of you does every day is really bringing that network. We started early on back at 55 Broad Street. This gentleman here was reminiscing about what the Rudins did with Lower Manhattan and in effect saving Lower Manhattan. And it was really about bringing people together and really about understanding that what we needed to do was to create a community and an environment where people wanted to be. And that's really what real estate's all about. It's all about the experience you have when you walk into that office building. What do you feel? Do you feel welcome or not? Do you get 5 bars on your phone or you immediately go to nothing? It's ultimately really seeing that and feeling that and being a part of that. So, the granularity, when you walk into 32 Avenue Americas, which was the only office building that the Rudins owned that they didn't build, we bought that in 1998. And that building was the original longline building of the AT&T network. And literally there's the mosaics, it's a historic landmark, and the mosaics are amazing. And you walk in off of Avenue Americas, 6th Avenue, and there's a huge mosaic of the world map. And it says, "Telephone wires and radios unite to make neighbors of nations." I always think of my grandfather worked in that building, that he would block out radios, because at the time when that was built in 1932, the way we connected to Europe were radios on buoys across the Atlantic. So on a calm day, good connection. Stormy day, not so good. And yet here we are again, full circle, talking about connecting telephone wires and radios in terms of wireless distribution and in-building wireless, to me as one of the most important issues that we can focus on and solve, simply because that's where 40% of the energy is consumed. It's the largest asset class in the world. It's all people. So how do we create an environment and an experience utilizing wireless spectrum that can create unique moments, creative moments, and the opportunity to make money? So I'll stop right there. Thank you, Rich. Thank you all.
John. I've got one quick question, John.
Sure.
Is Nantum an infrastructure or a software play or both?
Nantum is a software play.
Okay, so there's no hardware involved.
We have one little gateway that connects, basically grabs the data and then connects us to the cloud.
So what's your take on what SoftBank's goal is? Joe talked about SoftBank. SoftBank is buying Digital Bridge. SoftBank is coming to the U.S. What's your take on Digital Bridge and what they're doing? SoftBank and what they're doing.
What they've told us, and whether I'm allowed to talk about it or not, I have to be careful, but it's basically world domination. They're at the core, everybody knows SoftBank Vision Fund, but at the core, they're a telecommunications company. So what they're doing is what all of you should focus on as well. Is I've created a network. What are the applications that I can run over that network to create value for the person who's paying me? In Japan, there really aren't any carrier neutral risers. It's all telecommunications companies feeding, with a gateway and amplification into these very large buildings. For us at Rudin, we actually put in the infrastructure, never lit it up, was always dark fiber. But for those of you who have gray hair like me, 1995, there was a huge debate in Congress over, letting all these carriers in. They had blown up Ma Bell, right? AT&T was blown up. They were going after the baby bells. There were all these new companies, the MCIs of the world, the Sprints of the world. And what they were calling it mandatory access. So to property owners, it was like, okay, we just created 30 new telecommunications companies. You got to let them all in your building. I'm like, I got riser capacity that, as Darlene and I were talking about, we're grabbing the old mail slots and running fiber up through that because it was the only vertical, capacity that we had. So what we did was we said, wait a minute, time out. We at Rudin are going to put in the infrastructure and ultimately lease it or sell it back to the carriers. So we get a managed infrastructure, single mode, multi-mode fiber. Our job was really how do we deliver, and I'm coming from the world of 22.8 modems, connectivity, T1s, wow, you had a T3, holy cow. The ability ultimately to deliver optical fiber to the desktop was huge. So we did that and we never looked back. We've done it in literally every Rudin building. And why did we do that? We had Reuters at 40 East 52nd Street, building that's currently being torn down for the new Citadel headquarters on 52nd Street in Park. And we had Reuters in the middle of the building. They had a data facility in there. I had space that had come up above them. I couldn't get fiber to that space. Like, we can never, ever let this happen again. And that's why we went to the, Jerry Marmelstein, Riser Management. That's when we first met, Darlene. We said, this has to be a different model. And then what we did was, we said, okay, Verizon, New York Tel at the time, you have to ride this network. And they're like, no. We're like, yes. No, yes. Finally, yes, but they wanted to buy it. So we built it to their specs, sold them a chunk of the infrastructure, and then had room for the other carriers.
Gotcha. Oh. Any other questions?
Yes, sir.
The title of the speech here was about building having a brain, and a number of the stories that you had were use cases about a building being responsive to users. What's that next step where a building is actually truly autonomous?
I'm not sure I heard that, sorry.
You talked about the building having a brain.
Yeah.
And some of your examples it was around being responsive, like the right temperature, right lighting for every user. But what happens, or how do you make the building truly autonomous to deliver all that?
Great question. Our algorithms, I probably should have spent more time on this, but our algorithms are all about automation. So we take the data in, ultimately we memorize those patterns, and then ultimately as we alarm those patterns when they get out of whack, we now have automated the fix to those. So it really goes back to Eric Kandel, chemistry of memory. And it goes back to if my algos can allow the operating system of the building to think, predict, and then prescribe, and we can automate that, that's where the brain comes in. That's what our brains do, right? We were little kids, we fall down, we scrape our knee, we don't want to fall down anymore. We fall off our bike, we break our arm, we don't want to do that again. So it's no different than in building operations. Wait a minute, I got water consumption at 3 o'clock in the morning, time out, something's wrong, go find it and fix it. I've got, one of the greatest graphs, I probably should have brought a presentation, but when we had the eclipse in New York, and so our occupancy, we're watching our occupancy curve, and it like a pretty typical morning, everybody came in, went to lunch, they came back from lunch, suddenly they all left. and then they came back. So Nantum was like, hey, wait a minute, this has never happened before. So they're like kicking on it, chillers on, chillers off, chillers on, chillers off, and you could see the electrical curve trying to catch up to that information, that data. That was all automated. There was no human in the loop right there. It was simply the BMS being told, being signaled, this is our occupancy curve, and reacting to that. So we basically take that occupancy and temperature and do it everything. You know, we've got a graph right now where you can pull up any data source that Nantum is looking at and correlate it against any other data source to see whether or not that correlation can create value. That's really artificial intelligence. You know, we started calling it machine learning, right? But at the end of the day, it's AI.
Gotcha. Good.
Thanks, everybody.
Thanks so much.